Okay, in this video, what I'd like to do is I'd like to go over the difference between using normally open and normally closed contacts on your home/limit switch or home and limit switch and your e-stop buttons, and why it's important to stick with normally closed circuits. Don't use normally open on the e-stop or your limit switches. And I want to demonstrate why. First, let's look at the difference between the two. Limit switches very commonly come with three terminals: a common, a normally open, and a normally closed. E-stop buttons are buttons like this, 22mm variety. These are called contact blocks. And this button happens to have two contact blocks, and they happen to both be normally closed. You use normally closed contacts in e-stop buttons as well. Let me show a diagram here. Here's our limit switch, and internally here's the common. We refer to it as a wiper because it can swing back and forth depending on the state of the switch. And this is a normally closed contact. You'll see the wiper is in this state, closing that circuit. When the switch is actuated, this wiper swings down and closes the normally open contact. So in its resting state, it's closed. That's why it's called the normally closed. In a rest state, it's closed. When it's actuated, it comes down and it closes the normally open circuit. Same with this e-stop button. This is the button that you push, the head, and here are our two terminals. And in its normal state, it's closing these two terminals. When you push it, the button comes down and opens the two terminals. So let me demonstrate that. Here I have a meter, and it has a continuity test feature that it will audibly sound when a circuit is closed. Here's the other ends of the lead. So it's open, obviously. Now I'm going to close the circuit. You can hear an audible signal. So we're going to use these to test the states of our switches, our contacts. Let's start with the e-stop button. It's in its normal state. You see a black and a red wire. I'm going to clip my meter leads to the black and the red wire. And there you can see I've completed the circuit through the button because the button is normally closed. Now let me demonstrate when I push the button and actuate it. The actuators come down and opened the circuit. Now I'm going to release it, and it's back in its normal state. Machine is happy. Your control is looking for a normally closed circuit. In other words, it's sending a signal out and it's coming back. All right. The reason why this is important, again, we push the button, it opens. It's opening the circuit. The control sees it. Oh, I have an e-stop state. I'll stop. All right. The reason why this is important is if a wire breaks, the circuit opens and the machine will stop. The control will see an open circuit and the machine will stop. That's why you want to use normally closed. If you used a normally open circuit, the control is happy not seeing a signal, but as soon as it sees a signal, it will stop. Well, if you break a wire, it will never have the ability to see a signal. You're going to hit that button, you're closing a circuit, and the wire's broken. It will never see a signal, and you could have a big crash. Now let's look at the limit switch. Here's our limit switch. Here's common, normally open, normally closed. I'm going to hook to the common, and I'm going to hook to the normally closed. Same situation. Acorn is going to send a signal out, and it's going to come back to Acorn. If Acorn sees the signal back, it's happy, it'll keep running. Now when you home your machine tool is moving towards the switch, it hits it, Acorn sees an open circuit, it backs off. Home is set. Now, in the not so good scenario, hey, there's something wrong, you got to run away, it hits it, your machine tool hits the switch, Acorn sees an opening and immediately stops, says limit switch tripped, and you have to back off that switch until the circuit's closed again. So, this is using the normally closed contact. Now, if something were to happen and your wire broke, motion would stop immediately. Why? Because Acorn does not see that signal back to itself. It's going out and it's coming back to one of the inputs, and there's no signal there. So it stops. It says limit switch tripped, and maybe your limit switch is just fine. You go to your limit switch, you check it, oh, it's working fine. Why is Acorn not seeing the signal back? Because you broke the circuit from the switch to the Acorn input, or from the source to the switch. So that's where you want to continuity check your wires, from here to Acorn, from here the other common terminal. Let me demonstrate a normally open circuit. So this is normally open. So I'm going to clip on normally open. So let me actuate it. See? It has to be pressed to get a signal. So you can tell Acorn control says, hey, my limit switches are normally open. Say you want to home it. It'll go. It hits it. Oh, say, okay, I see the signal. Now I got to back off. And everything's fine. Machine will move, machine will move. Now, if you lose that circuit and you're, for whatever reason, you're about to hit a crash, you close it, Acorn never sees a signal. If it doesn't see a signal, it's just going to crash until you hit a hard stop. So that's why you do not want to use normally open contacts on limit switches, home switches, or e-stop switches. Now let's go to this linear slide. This is what we're going to be using in the Acorn demo series here, just to demonstrate it. Okay. You can see the lever is not touching the block. And it's a normally closed circuit. So I've programmed Acorn to look for a normally closed signal from my limit switch, and it's looking for an input. So it sees an input. You can see the circuit's complete here. Instead of the meter, it would be Acorn in its place. So I want to home my machine. So here we are, we're going to home the machine. So you can see the block moving, it's hitting the arm. There, it opened the circuit. Acorn will back it off until it sees the circuit close again. There, and it will stop. So now your machine is homed. Now let's go another scenario. You're machining something, or you didn't set a tool offset right, or you lost a bunch of steps, or who knows what. But now your machine is heading towards the end of the travel, and it's going to hit that switch. There, the circuit opened. Acorn will stop the machine and say a limit switch has been tripped. Okay? Let's back off again. So a limit switch has been tripped. Now you're going to manually jog off of it. Okay? So now you're off the switch. Acorn sees a complete circuit. Now you're happily machining along. Remember, Acorn's seeing a completed limit switch circuit, and all of a sudden the wire comes loose. Acorn no longer sees the circuit and will stop exactly where the machine is at. Just as we described with the e-stop button, if you mash the e-stop, the circuit opens and Acorn will stop with an e-stop error. Now, let's suppose you didn't use a normally closed switch and used a normally open switch. I move this from normally closed to normally open. I'm going to hook it on. You see, you hear nothing because right now the switch is in this state. The switch is in this state, and nothing will happen until the switch trips and closes. And right now, if you've told the wizard that you're using a normally open switch, it says, fine, I'm good with that. So now you're going to home your machine, and it's going to wait till the switch closes. Okay, there it is. I see a closure. Now I'm going to back off until it opens, and it'll stop. Home is set. All right. Now let's disconnect. Now you have a catastrophe about to happen. Your machine is heading to the switch, and because Acorn sees no closure, you crash and you hit the hard stop in your machine. So this is precisely why, because the circuit never closed, Acorn never saw a closed circuit, you had a crash and your machine hit the hard stop. And you're lucky if that's all that happens and nothing breaks. So I hope this helps explain why it's very important to use normally closed switches in both limits and e-stops versus normally open. It's primarily so that the control sees a signal always at all times, and it will not stop until that signal opens, whether it be a trip or if a wire breaks or loose connection occurs, and it stops. And that is the safest way to set up your machine.